So we're talking about the fundamental counting principle, and it's useful for the counting the number of ways a series of procedures or events can take place. The key is that the first procedure or event does not affect the second procedure or event in any way. The second event does not affect the third event, and so forth. In other words, each event is independent of the other events. So, if we want to determine the number of ways each individual event can occur, we're going to multiply all of those number of ways together to get the total number of ways that series of events can happen. Using mathematical symbols or notations, we call the number of ways the first event can happen as case of 1. The number of ways the second is case of 2, and so on, with the number of ways the last event can happen as case of n. Then the total number of ways the series of events can happen is multiplying those. Case of 1 times case of 2 times case of 3 all the way down to the last one. So basically you're going to multiply the number of ways each event can happen. So for example 1, we want to know how many different ways or how many different passwords can be made that consist of one uppercase letter followed by one lowercase letter followed by 3 numbers, if the numbers are able to be repeated. So that's the numbers and the letters. They can be repeated. We worry about the numbers especially because we're using 3 numbers. Since we're only using one uppercase and one lowercase, then we don't have to worry about repetition so much, but in what we're doing, we're not worrying about whether or not it repeats. All right, so example 1. We are looking at a lowercase, an uppercase, and a number. So what we have to know is how many are there of each. So a lowercase letter, we need to know how many letters are in the alphabet, and there are 26 letters. There are also 26 uppercase letters. And then for the numbers, how many single-digit numbers are there? Well, you have to, a lot of times we think, well, there's 9, but really 0 is also a single digit. So we're looking at the numbers 0 through 9, which tells us that it will actually be 10 total numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 10 digits that we can use for our numbers. So with our password, we would take the first case of the uppercase letter times the lowercase letter possibilities times a number 3 times, because those numbers, there's 3 of them. Now notice I don't multiply by 3. I use each one individually. This event, this event, this event, this event, this event. And then you're going to multiply that. And you will get 676,000 as the possible passwords, different passwords you could create there. So that's why there's like so many different things out there, different websites and all that, because the more you use, the bigger the number grows. All right, let's look at example 2. So for example 2, we've got a local restaurant that offers a lunch special where you can select an appetizer, an entree, and a dessert for $12.99. There are 4 appetizers, 6 entrees, and 3 desserts to choose from. How many different meals are available? So we are looking at, there's appetizers times the entrees times dessert. And there were 4 appetizers times 6 entrees times 3 desserts. So there's 72 different ways you could order your $12.99 meal. Now, does that mean they change a lot? No. Because you could order the same appetizer and entree, but then just change your dessert. Or you could order the same appetizer and dessert and just change the entree. So it doesn't change a lot, but there are 72 different combinations of how you could serve this or choose to do that. All right, let's look at our next example. Bill has 7 shirts, 4 pairs of pants, 3 pairs of shoes. How many different outfits will Bill wear, or can Bill wear? So we're looking at Bill's clothes, and he has shirts, he has pants, and he has shoes. So he had 7 shirts times 4 pairs of pants times 3 pairs of shoes. Now, when he changes these outfits, they're not going to change very much. He could wear the same shirt and pants and just change the shoes. Or the pants and the shoes, he's just changing the shirt. So it may not look always that much different, but he can still create how many outfits? Well, 7 times 4 times 3. He can make 84 different combinations of outfits with the 7 shirts, 4 pairs of pants, and 3 pairs of shoes. All righty. Let's look at another example. So example 4, we are looking at a number code is made using the numbers 0 through 9, a 5-number code. How many codes can be made if the numbers can be repeated? So that means we don't use one and then can't use it again. We can repeat. So we can still use all 10 of those digits, but we're making a 5 code. So since we're doing 5 numbers, it's 10 times 10 times 10 times 10 times 10. It's just being multiplied by itself 5 times. So that's going to get you 100,000. Different ways you could do that 5-number code just by using numbers and only using 5 of them. All right, let's go to example 5. So for example 5, how many possible outcomes are there when you roll 5 dice? So when they just talk about dice, we're looking at a 6-sided dice. There are other sides of a dice, but for this we're just looking at a 6-sided dice. So example 5, we're using a 6-sided dice. And how many possible outcomes if we roll 5 of them? Well, there's 6 sides, and we're going to do it 5 times. So we've got 1, 2, 3, 4, 5 dice written out with 6 opportunities on each one, and that will get us 7,776 possibilities. So if you play the game of Yahtzee, every time you roll those 5 dice and rolling all 5 of them, there's that many possibilities of what you might roll. All right, let's look at number 6. If you flip a coin 10 times, how many possible outcomes are there? So if we're flipping a coin, how many sides are there to a coin? Well, there's 2 sides. There's heads and there's tails. So there's 2 sides each time you flip it, and we are flipping it 10 times. So we have to write 10 twos. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we've got 10 flips, 2 sides each time. So that gives us a possibility of 1,024 different outcomes. All right, example 7. So we have in an Italian restaurant, you can choose from 4 types of pasta, 6 types of sauce, and 3 salads. How many different possible dinners are there? Well, we have 4 types of pasta times 6 types of sauce times 3 salads. So that would be 4 times 6 times 3. And when we multiply that, we'd have 72 possible dinners that we could order.